everyone, welcome back, and I am so excited because we have Harrison Chase, who is the CEO and co-founder of LangChain, one of the most exciting open source frameworks for building and designing applications with LLMs. I'm sure you've all heard of it already, but Harrison, thanks so much for being here.
Thanks for having me. I'm really excited to be here.
Awesome. Well, I want to dive straight into something that you've been talking a lot about online. Recently, over the last several years, we've heard so much about model weights. There's a ton of people talking about that, but even though they get a lot of attention, AI agents actually learn at what you call the agent harness layer. So for our audience, what is an agent harness, and why is agent harness engineering as crucial as prompt engineering and fine-tuning?
Yeah, it's a great question, and one we've been thinking a lot about. So an agent at the end of the day is an LLM running in a loop and calling tools, and that sounds simple, but where the harness comes in is it's that scaffold, it's that harness around the model that connects to the tools, connects it to the environment, helps it basically orchestrate what is going on. And so over the past few years, we've seen this idea of an LLM running in a loop calling tools evolve, and more things go into the harness. So things like skills and sub-agents, which are becoming key parts of these agentic systems, are now part of most harnesses out there. And so we've started to build up this idea of what a harness should be. That being said, the right harness is still specific to kind of like the task at hand. You might want different tools for a particular task, and at the very least, you're going to want different prompts as well. And so there's kind of this layer around the model that connects it to external sources of data and computation, and that is the harness. And changing that harness can be just as effective and oftentimes way easier than changing the weights of the underlying model. So one of our researchers did a blog recently where there's Terminal Bench. Terminal Bench is a great benchmark for coding tasks. He took Deep Agents, which is our open source model agnostic harness. You can use it for other things besides coding, but coding is a great use case. So he took that and we went from 30th to 5th just by tuning the harness. So no changes of models, nothing like that. And so I think that shows like how much alpha there is in kind of like changing the harness. And that's where we spend a lot of time. We spend a lot of time thinking about harness engineering and how we can make it easier for folks and how people can build their own harnesses that are specific for their applications.
Yeah, it seems like there's a lot of flexibility, agility, and power in focusing on the harness layer, especially when you have more control at that layer as well as a developer.
I think, yeah, I mean, a big part of, like if you think about building an agent for a particular task, like what makes it different than like just ChatGPT? It's all of the context and tools that it has. And so then how does it access those contexts and tools is a key part. One of the really interesting trends that we've seen, for example, is using a file system as a generic way to give it access to tools and actually to run tools, like run scripts, and then also access just knowledge in terms of like markdown files. And this is because LLMs are so good at interacting with file systems. And so there's this interesting thing as well where there are properties of the LLMs that make certain parts of the harness better or worse. So these LLMs are really good at interacting with file systems. Let's give them a file system. Now the fun part here is the file system doesn't have to be like a real file system. It can be like what we call a virtual file system. So in Deep Agents, we have this concept where you can store all this knowledge in a database or something like that, but still expose it to the LLM like it's in a file system. And I think this is one of the clever tricks of like harness engineering. You basically take this data and you expose it in particular ways that are best suited for the model to use it as part of this harness. And so there's a lot of really clever tricks you can do.
Yeah, a lot of interesting tricks. I do want to touch on how the model actually does help influence the harness, but before I touch on that, we do know that a lot of developers use LangGraph for code, state logic, and complex harnesses. So here at Google Cloud, we've built our reasoning engine as this secure, managed environment for deploying LangChain and LangGraph for your applications. So in your view, what is the value of combining an open source framework like LangChain or LangGraph and a managed infrastructure like our Gemini Enterprise agent platform and the included reasoning engine?
Yeah, I think building an agent that works locally is just kind of like step one of the journey. And it's actually, it is a long journey to go from an agent that works for like a Twitter demo to something that's running in production. And part of that is getting the agent to behave well enough. And that's where all of the harness engineering or using LangGraph to create more deterministic workflows or more specific workflows can be really interesting. But the other part is scaling the agent up. Having it, like agents they're long-running and stateful applications. So how do you keep an agent running for a long amount of time if the process for some reason dies halfway through step 21? Like, do you resume from the start, or do you resume from step 21? When you have a bunch of incoming requests, oftentimes we see that people kick off like thousands of agents in parallel. How do you scale up? How do you scale your infrastructure? All of that is benefits of a managed runtime, and so I think that's a lot of the benefits we see with the partnership with Google.
Nice. And as I understand it, we've also built reasoning engine in partnership. Can you tell us a little bit about the collaboration?
Yeah, that was like 2 or 3 years ago. I'm trying to remember when LangChain first came out. There was, I think it was like LangChain on Vertex or something was the original name of it. The name we're not great at naming. You guys have changed namings a bunch as well, so I don't know what the original name was. But I know early on, I think there was something like LangChain on Vertex, and that's evolved to a lot of what's in reasoning engine today. And it's basically just makes it easy to run open source frameworks, including LangChain and LangGraph on Google infrastructure.
Nice. So just talking about improving harness code, you've noted that improving it requires traces or logs of every agent step. And a lot of our users actually run agent workloads on Google Cloud, but they might use something like LangSmith for these traces. So when we're reviewing these traces, is there anything that you look for, a signal that a team should then go ahead and know that they should optimize or rewrite their agent's code?
Yeah, I think there's a few things you can look for. Some of it is kind of like user feedback, whether it's direct or indirect. So everyone knows about like thumbs up and thumbs down, and you can put that in the chatbot, and if the user gives a thumb down signal, you probably want to look at the trace to see what went wrong. But there's other kind of like implicit user signals as well. So if I say something to the chatbot like, no, you did it incorrectly, I didn't leave a thumbs up or thumbs down, but by looking at my reaction, you could tell that there was probably a mistake that was made. And so one of the things that we do in LangSmith, and LangSmith is our infrastructure for observability and evals, and the reason we think they're tightly coupled is exactly this reason. We have what we call like online evals. They run over all of these traces that come in. We spend a ton of time to like make it really easy to ingest traces at scale, query them at scale, and then do kind of like transformations and get insights over them. And so one of the things is these online evals. You can run what we call kind of like an inferred error eval. And so if you see me as the user say something to the agent like, no, you did that wrong, or like, okay, but that's not exactly what I meant, you might want to, we'll basically leave a little signal on the trace that's like, hey, this is bad. There's an inferred error here. Side note, this is where Gemini Flash comes in really handy, because you want to use a cheap and fast model for these online evals, and so I think that's a great use case for Gemini Flash. So there's all these signals you can look at and start to attach to these traces, and then once you have these traces with these feedback in LangSmith, whether it's real user feedback or these online evals, you can use that to query traces, slice and dice traces, track kind of like things over time, and then manually, or everything in the SDLC is getting automated. And so you can also use an agent to look at these traces, suggest changes to your agent code, to your agent prompts, and this kind of like life cycle of agent improvement is really centered around traces, and that's what we've built with LangSmith.
That's awesome. Yeah, I feel like the couple of things I've noted is actually using AI effectively across the entire SDLC and picking the right model for it, and doing things like inferred errors, which I think is a kind of a mindset shift. It's like you don't have to have the clear, explicit thumbs up or thumbs down in this case.
Yeah, and I think like there's evals that we can provide off the shelf as LangSmith. So this inferred error is one. We also have another one where we see if the agent's basically running in a loop and calling the same tools repeatedly, which suggests that it's getting confused or making mistakes. But I think another really important thing is that a lot of these evals are application specific. Like what a legal AI what a good response for a legal AI might look like is pretty different than what a good response for a financial AI might look like, and you might want different signals for different ones. And so another thing that we spend a lot of time on is making it easy for people to create their own evaluators that are tuned for their domain. And so I do actually think like the percentage of off-the-shelf kind of like evaluators that you can use is going up. But there's still like a really good chunk of them that you're going to have to build yourself as an agent engineer or something like that, and so we want to make that easy as well.
Yeah, just that little last mile that you might have to fine tune, even if it is off the shelf.
Exactly.
Okay.
Exactly.
Well, talking a little bit more about the models, I wanted to get to this. So the harness obviously wraps around a foundational model, and so here at Google, we know that Gemini has some pretty unique capabilities like multimodality, expanded context window, ability to do advanced function calling. So how does that impact harness engineering? Does it allow you to have more simple harnesses or enable more complex workflows?
Yeah, it's a really good question, and one of the things that we're still, I'd say as an industry, like figuring out. So maybe for the first like 2 years of LangChain, I think there was a lot of, I wouldn't even call it harnesses. I'd call it kind of like scaffolds built around the model, where you're not, like the idea of an agent and the idea of an agent harness is that you run the model in a loop and let it call tools. And then there's like small deviations of that, but like that's the core idea. And a lot of LangChain and a lot of the more deterministic LangGraph flows, they weren't that. They were structuring it in more ways. And a big reason why that was the case is the models weren't good enough yet. And I'd say about a year ago, the models started to get really good, and they started to get good enough to actually run them in a loop. And so so that's when these agent harnesses started to be more common, and that's when we started to figure out kind of like the primitives to put in these agent harnesses. Now they're still evolving. So context window is a great one. Like long context window lets you run the harness longer without having to do a compaction event. So a big part of a lot of the harnesses today is compaction. When you reach a certain kind of like threshold, you'll condense all the information into a summary or something, and then resume from that. The longer the context window, the less you have to do that, and usually the better performance. Multimodality is a good one as well. So like I mentioned file systems earlier. The agent's really good at interacting with file systems. When it sees an image file in the file system, what does it do? If it can't handle kind of like images, then it can't really work with that effectively. Same with videos. So I think one of the big places where we've seen Gemini be popular is in these multimodal settings. And I think like, so some of these things are just like net new features, like supporting multimodality, great. That's something that you can just like add into the harness. Some of them, like the context window, change kind of like the importance of things in the harness. And then another really interesting thing, which I think we're still, again, figuring out as an industry, is like, how specific does the harness need to be to the model? So what I mean by that is that sometimes these models are trained on particular functions or particular instructions. And so you might want to have like a base system prompt in the harness, or even the tools that are exposed, you might want those to be specific to the model that it's interacting with. And so we're doing a lot of research on this now to try to figure out, hey, we're using OpenAI versus Anthropic versus Google models. What does the difference need to be in the system prompt, and what tools need to be the same or different? But at the same time, there's also this, like, the whole point of these models are their general purpose, like intelligent beings. So like, how much do these differences matter? And does having a harness that kind of like works well across all of them, is that actually more general purpose and more robust to changes in the future? I think this is kind of like an open question in the industry right now.
Yeah, and it's actually interesting because you've been around since basically the heyday, the beginning of these LLMs. So how have you seen the evolution of the capabilities of the foundational models, and alongside what you've been building at LangChain? Like, has it really changed your trajectory as well?
I think there's some things that have changed and some things that haven't. So one thing that has absolutely changed, and I alluded to this a little bit earlier, but like the models have just gotten good enough where we can build actual agents. So I don't know if you remember AutoGPT.
Yeah.
It was like fastest. It was like the early version of OpenClaw, right? It was like the fastest growing GitHub project, and it came out a few months after LangChain, really early 2023, took off like wildfire. No one really uses it anymore. Why not? Like under the hood, it's the same architecture as OpenClaw, basically. It's a model running in a loop calling tools. The issue was the models just weren't good enough at the time. And so that's why we invested in LangChain for chaining things together, and then LangGraph for more deterministic workflows. But now I think these models are good enough, and we're seeing a lot of interest in deep agents, which is our agent harness. And so that's been like the big changes. Basically, AutoGPT wasn't really viable. Now it's viable. That's the change in the models. But there are some things that don't change. So one of the key things that we think doesn't change is it's really easy to build a prototype, but it's hard to get it into production.
Right.
And you need to, and in order to bridge that gap, there's some infrastructure concerns, but there's a lot of just like reliability and performance concerns. And this is where observability and evals has always been a key part of that journey, and I think always will continue to be a key part of that journey. You can't really improve if you don't know what happened, and that's where observability comes in. And then when you do improve, these LLMs are great, but like they're not robust at all. You make one change and like something else might go completely off the deep end, right?
Yeah.
And so you need like a good robust eval set to make sure that you're doing regression testing and actually kind of like consistently improving. And I think no matter what like the LLMs do, no matter what the agent harnesses do, no matter what they look like, whether they're graphs or whether they're these LLMs running a loop, you'll always want observability and you'll always want evals.
Yeah.
So it's been interesting to kind of see what's changed and what hasn't.
I think observability and eval is going to continue to just be one of the most important topics, like throughout not only this year, but just ongoing. And I know a lot of folks have been talking about it a little bit, but now it seems like the attention is all on eval and observability, especially for these more serious use cases as people realize how important reliability is. The other thing I want to touch on that you mentioned that's really like a trend that I've seen is being ahead of your time, developing this orchestration beyond maybe some of the other technology that it relies on, needing to catch up a little bit. Like when video streaming became huge back in the early 2000s, there were a lot of companies building video streaming platforms, but the infrastructure of the network just wasn't built enough yet. And it seems like with foundational models, it's kind of the same thing. So now we can really focus on the core agent logic, eval, and benchmarking at that instead.
Yeah, I think in some ways, it's fortunate that it took like 2 years, 2.5 years for models to get good enough to power a lot of these agents, because we could build some of this infrastructure. We could build observability and evals, and I think now that agents are starting to work, we have some of this stuff in place that can help kind of like supercharge some of that. At the same time, like I think the landscape is crazy. It changes like every week, every month. Like there's new capabilities that come out, and so I do also think that it's still even the models are in a way better place than they were 2 years ago, 3 years ago, but it's still so early, and there's so much that will change as well.
Yeah, which makes it exciting too.
Yes.
So one thing about just looking into the future, something that you've highlighted recently is something called meta harness. So this is where, as I understand it, this is where agents can analyze logs to suggest code changes. And so with this, I know that with Google Cloud, we have something called Gemini Code Assist, which is our AI-powered code assistance at every layer of SDLC as well. We also have LangChain orchestration. So with the two, do you see that this is becoming a reality with meta harnesses? Could agents soon maybe automatically rewrite their Lang graph or a code on Gemini Enterprise Agent Platform, for example?
Yeah, I think that is a reality. I think and the way that I think about it, so there's two things that I add. One, I think you've got like 2 of 3 pieces, I think there. You've got LangChain as like the code, the infrastructure, LangChain, LangGraph, deep agents, the code for running the agent. You've got Gemini Code Assist for kind of like rewriting some of the code. The thing that you also need is the visibility into what the agent did, because basically the way this loop works is you run the agent over a bunch of data points. You then see what happened and whether it was good or whether it was bad. This is where you need evals. And then you feed that back into the agent and have it rewrite the code and then run in a loop. So I think if you take kind of like the harness with LangChain, LangGraph, deep agents, you take LangSmith, observability, evals, you take Gemini Code Assist for some of the code write, that's kind of like the loop that will turn it. And one way to think about this is that's something that we as humans would do manually. Like that's the job of an AI engineer, like to basically run the agent, look at the data, see what went wrong, suggest changes, have hypotheses for like what would work. But everything in the SDLC is getting automated. And so is that like turning of the flywheel. And so I think that's something that is still really new. And like right now, it is absolutely more kind of like researchy and Twittery and experimentally. But like I think that is totally viable. I think a really interesting question arises there is like, where do you put the human in the loop? Like, do you actually push these code changes, or do you create a PR first? And what are you actually pushing? Are you pushing code changes, or are you changing like the prompt or the memory or the knowledge base that it has access to? I think there's not necessarily any kind of like one right action. I think there's actually a bunch of different actions that can kind of stem downstream, because there's a bunch of different things that AI engineers can do. And so in some way, how we think about like the next evolution of LangSmith and LangChain is we're really creating this like AI engineer, like right. And so that'll help kind of like spin this like data flywheel or improvement flywheel.
Yeah, it's interesting because as we develop best practices around all of this, then something changes and then there's another best practice, and it's all very personal too to everyone's workflows. So what are some of the things that you're most excited about in terms of what you're building now, and it's going to really impact like where we're going in the future?
We've talked about a lot of them already. I think agent harnesses are one. I think like what is the right way for agents to interact with their environment, and I think we have some idea of what that looks like for coding, and I think to some extent that's general purpose. But I think there are absolutely kind of like nuances for different domains, and how can we make it easy to test and build these agent harnesses. This improvement loop, taking the traces, taking evals, suggesting changes, like that's really interesting to us. Maybe the third thing that I'd call out, and this relates to the improvement loop and the agent harness actually, is memory. Memory is a really, really interesting topic for us. I think right now, memory is tightly coupled to a harness. There aren't really standards around what memory should be or what it should look like. There are some, like you could argue that like agents.md and skills are like a form of memory. But like, you know, you could also argue they're not, and like there's probably other forms as well. So right now, like memory is really tightly coupled to an agent harness. Maybe that'll change in the future, but right now it's really tightly coupled. And then memory, like, you know, so that ties to agent harnesses. It also ties to this improvement loop, because I think definitionally by memory we mean something that kind of like improves over time and that learns from past experiences. And so I think like you know, we've always had these kind of like two sides of LangChain. We've had the open source with agent harnesses, and we've had LangSmith with observability and evals. And I think memory is kind of like the bridge that connects them in a lot of ways. And so we're spending a lot of time thinking about like what that looks like, how that interacts with harnesses, are there standards for that, how that can be improved through this like flywheel. And so I'd add that as a third thing that we're really interested in.
I know it's a really hot topic because everyone tries to improve their agent systems. So excited to see where that space goes with memory. But thank you so much for joining us for this live stream. I know that we have limited time, and I hope you enjoy the rest of Next.
Thank you for having me.